All right, testing. I'm going to start up video, but there's no one here yet. Let me send this off to other people in case anyone's still interested in doing this. So I'm hoping this is the right, uh, right. So let me have a quick view on Zoom. Oh, hey, hello everyone. Um, just let me know if there's something that you need or you can't see or I'm making an ass of myself. I'm going to open up Visual Studio and plop it over on my other screen here and then share everything with you guys. Nice. Nice, Eric. Love the background. Um, so let me see what I can do here. And sure. All right. So I didn't know what you guys wanted me to go over, or if you just hear learn by osmosis, just wait until somebody else asks a question and hope that that's what I did as a student oftentimes. Show up, hope somebody asks something interesting, or maybe you'll learn what kind of question you want to ask after somebody else asks something interesting. But I'm open for whatever kind of question you want to cover today. Uh, that's what these are for. They're not a lecture, they're not new material necessarily. They're just rehashings or different ways of looking at this, help with the assignments, that sort of thing. So we can go over things in the assignment. We can go over how functions work, which is this week's topic. We can do whatever you guys want to look at. Is there anything that's confusing so far? Printf statements? How to mute your mic? How to type in the chat, maybe? I don't know. I'm joking. It's kind of hard for me to give a tutorial without knowing what direction you guys want me to go in. Do you want me to go over? I did a programming guide earlier. I don't know if any of you had a chance to see it. This is actually some of the code from it. Not really meant to be code per se. It was meant to be just we'll do code just as the illustrative example, but not necessarily. You're not supposed to know what the heck a while loop is, for example, right now. Uh, but Clock Lab. Okay, two different great two questions. So, do we have void functions? I'm assuming is what you're. Oh, you mean functions without a name, as sort of anonymous functions? They're called lambdas. I think I found out technically. I didn't know what one was. My students had to tell me, and even then, I'm not even sure about it. This is for other languages. We'll have lambdas, which is a function without a name. Just it's the sort of the descriptor, but you don't ever need to refer to it directly. It's just automatically just it's a function within the function essentially. Um, I don't do that very often. So, do you mean functions within functions, or do you mean what's hard to describe, or do you mean just a void return type? See? And Jeanette, I'm going to be looking at. I'm mostly in trouble with the clock lab. We can do the clock lab. Let's have a quick look at that. I think the clock lab will actually cover a lot of this stuff. And hey, I can give away answers for the lab. That's fine. The labs again are just to get practice. So here's what we're going to need to do for the clock lab. I'm going to do a whole bunch of functions. Functions are this week's topic. And yeah, although I don't know, this is one of those things that I know I avoided breakpoints for way too long. 2 years, something like that. I'm like, oh, that's too complicated. It was more complicated in old versions of the system. And then someone showed, I know, I finally had to use one day in industry finally when I finally got out of undergrad, went to university, and then I suddenly hit, needed a breakpoint, and it just, oh, that's it. Okay, so we'll go over that. Okay, so I got my stuff here. Go over breakpoints. It functions the same way in C++. Yeah, almost everything, things are going to look almost exactly the same. There's just some extra stuff. It's to the point that you can write pure C code in C++, which is actually what we've been doing, and no one knows. And you accidentally sneak in a C++ thing in there, and it doesn't tell you that anything's wrong. Assignment 3, the program set up a segment where you print out statements. You asked us to comment why we get different values of the print statement. I think I mostly understand why that is, but I want to explain it a little bit. If I explain it though here before the assignment's due, then I give away an answer. So Fiona, I would love to explain some things. Uh, I can definitely explain it next week for sure. We can sort of go around the situation, but the point of it is you coming up with the explanation. It doesn't have to be overly elaborate. It's like if you try and print out a float, but you claim it's an integer, you're going to get what looks like garbage. Why? Because under the hood, the binary is not the same, right? The zeros and ones used to represent a floating point number are radically different than what that you used for an integer. And so when you do a printf statement and you claim that it's an integer, but it's actually a floating point number, it doesn't look right. And that's good enough. The binary is different. The underlying mechanism is different. If you're trying to print out, what other examples do we have here? We had some uninitialized variables. We had things where the numbers were wrong. So if we had 3 divided by 4 multiplied by some double, multiplied by some double, what's 3 divided by 4 is integers. If I have purely integer division, I don't get 0.75. It's purely whole numbers. So if you're teaching to a little kid, like what's 3 divided, they don't know division either. If let's say you have a kid that understands division but doesn't understand decimal points, right? 3 divided by 4, and they go, what is it? Well, how many times can 3 go into 4? Well, it doesn't go all the way up there, right? If you have 3/4 of a pie, do you have a whole pie? No. How many whole pies do you have? 0 whole pies. I got 3/4 of a pie, but not a whole pie. And that's essentially your explanation is 3 divided by 4 as an integer arithmetic gives you 0. And therefore all your math afterwards is wrong. I don't want to get to the nuts and bolts of that because I don't want to just give away answers on that on the homework. But it's a good thing to point out. Yeah, all right. Perfect. So our problems clock lab. I'm going to do some clock lab things. I'd like to point out the void thing, hopefully, and we'll go over breakpoints. Because we're going to do breakpoints for that clock lab. I'm guarantee you I'm almost going to make a mistake in there somewhere. If you write functions the same way in C++. Yeah. So essentially, writing functions the same way in C++ as you do in C. There is a slight difference, right? In C++, if you have an object, you have a header file, you have a CPP file. We'll get to those next term. But you have 2 different files oftentimes, and you have an object. And so there's this weird thing going on in C++. This is going to straight up look like find factor here that you should be seeing here, right? I have what's going in the input box. Here's the output, what pops out the other end. And it looks like that for things like cosine of x. What's cosine of x look like? It's cosine, and then it has parentheses, some number put inside, and it spits up something on the other end. Oh, wait, that's exactly what we have here. It is literally mapping to what you see in mathematics, right? If I was doing some math, I'm just going to start modifying this thing here. I move my headphones around. All right. So this is me playing around with what we were doing in a how to program guide. So what's cosine of 30? I have an input, the 30. It spits out another number. And so something like this. So things are going in, the 30 is going in, something's popping out on the other end of this cosine, and it's being caught and stored in a variable called my cos or my cosine, right? It imagine if it's a magic box, that thing, like not literally magic box, right? But it's just the concept. I have a box. It's this thing that I dump stuff in, turn the crank, and stuff comes out. You can think of it like a sausage making machine, right? You put sausage on the top, sausage goes in, you're turning the crank. I think you turn a crank for a sausage maker, right? You turn the crank, and sausage is going into those little shelves. They're casings on the other end, right? You just turn the crank and things are coming out. That's what we're doing with a function. So we'll do functions now. Most of the time, if I have a void function, it means there's nothing coming out the end. Things are going in. Something happens. Printf is a void function, as far as I know. So when I call printf on something, nothing's really coming out. It's printing something to the screen, fine, but nothing's being returned back to me. The other time, it's like me throwing a ball, it catching it, and throwing something back. And so with a printf function, it's a void function. Main can be a void function, so I could put void in main here. It's a different main function. They're different flavors of the main function, but it's still a main function. Okay, I want to make sure I'm not missing any other parts of the chat, and then let's go over the clock lab just to give some people an idea. Before I get going, let me think about what my problem is. Okay. Uh, let's do this. Sync vector clock lab example. This is my thought process. Okay. So what do we have with the clock lab? We're going to need some kind of number. That is the number of seconds that have passed, something like that. Okay. I want a random number because I want to have a certain number of hours, minutes, and days. Sorry, hours, minutes, and seconds in the day. So just I want. So if I give you how many days since 1970, how many seconds since 1971 have happened, you can actually calculate how many what exact date it is. Yes, you actually can, and it's not actually that hard. It's hard for us if we're trying to break out the pen and paper, but it's doable, right? So if or you can figure out how much time is left. Oh, we can reverse engineer this. We can figure out what the end date of the term is, the current date and set time of the term now, and figure out how many seconds for the rest of the term. Work in reverse, if you will, right? It's different scales, right? It's like converting from kilograms to pounds, right? They're just you one convert one to the other. So what I have here is number of seconds. Um, is it number of seconds in a certain period of time, or is it number of seconds that have passed? I always forget. Say since yesterday. No, not since yesterday. Since some start time. Okay, so if I say some start time is at midnight, 1971, that's called an epoch time. It's just there's a time where things start. We have a bunch of those, depending on your calendar, depending on your religious beliefs, depending on a lot of things. One of our religious beliefs, so to speak, epoch time for when Unix was first rolled out. That's an epoch time. They actually have that encoded, and if you get the time from a system in, let's say, I think on the Mac, in Unix, and a couple other places, the time will be based off of when Unix was first released to the wild, and all time since that point in time. So I have some start time. It could be 1971. I think it's 71 for epoch time. Could be 40, could be any time. Okay, I have a certain number, but that's the number of seconds. And now I want to figure out How many days, hours, and minutes since that time? Okay, that's the task. So I need to figure out. So I want to follow my own example that I was giving there, how to program. I want to think about, okay, how do I code this up? Okay, let's do some very simple examples. I really want to play with this. I want to understand what the heck is going on. This is not the random part. The random part will give us a number of seconds that have passed. We can go over that too. I'm more than happy to go over that too. But this, for the programming side of things, it does not require any conditionals or anything special like that. It's just straight math. So if I have, let's say, 344 seconds, I want some relatively small number. How many hours, minutes, oh, not days. I don't want days. How many hours, minutes, and seconds? So we can throw away the days, or we can keep the days if we wanted to. So if I have 344 seconds that have passed, what is that in hours, minutes, seconds? How would I break that down? Well, if I divided it by 60, what do I get? So that would be how many minutes have passed. Right? 60 seconds in a minute. Okay, I'm going to need a calculator unless you guys have a calculator ready to go on this one. Anyone know what the answer on that is? Because it's 5 minutes. So it would be 300 seconds. 5 minutes and 44 seconds. Right? 30 times 300 is 60 times 5, because 6 times 5 is 30. So add another zero, 300, 6 times 5. And then I have 44 seconds remaining because it hasn't gone to the next minute. Okay. So then it's 0 hours, 5 minutes and 44 seconds. Now, if I give some really, really big number, so let's put some really, really big number in. I'll need to 0, 1, 2, 0, 3, 0. Random number. Well, what I'll need to do is if I divide it by 60, I'm going to need the calculator on that one. So I'm going to break out my handy dandy calculator on this thing here. All right. So if I have 1, 0, 2, 0, 3, 0 divided by 60, 1,700. And then I need there's a certain remainder, right? So 0.5. So if we take that, so this is the number multiplied by 6. No, I don't want that. 1700 multiplied by 60 that's a really big number here. Oh no, because I multiplied it twice. Clear, 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 clear. 700 multiplied by 60. Okay, minus 10230. Okay, 30 seconds left over. Oh, thank you. Okay, now what do we need? I don't know how many hours have passed. So what if I take that number of minutes, right? They're whole numbers, not zero point 0.5, because they're integers. I don't get to do like 0.5. There's no way of storing that. That's one of those things that you just have to come to terms with. Programmers are they're lazily efficient, and they don't want to be dealing with, fractions if they don't have to. So I like whole numbers. Most programmers like whole numbers. Why? Because the math is easier and you can deal with it easier. And they're smaller numbers to store with as well. So if I take this number here, 1700 divided by 60, that's 28 hours. So if I could type, so 28 hours. Oh, wait, how many hours in a day? 24. Or if we were on a 12-hour clock, I would need to divide it again, right? Divided by 12. So we'll have to do that one more time afterwards. And then I need to figure out how many minutes are left in this thing. A third, so 20 minutes, 20. Or, okay, so that's 4 hours, 20 minutes, 30 seconds. Start time. That's what we're doing, essentially. So if you want to figure out the distance between two times, you give me one time in seconds, another time in seconds. I can calculate how many hours, minutes, and seconds that have passed. I just keep on doing division and remainder, division, remainder, division, remainder, and I'm done because it cycles. And as soon as I go past 60 seconds, I get a minute. Go past 6 seconds again, I get 2 minutes. I do the same thing again for other numbers. Okay, now I need to worry about where things can go wrong. Where could things go wrong? You give me a negative number of seconds. Okay, that might be a problem. Or I could just let the math do its thing and just say, well, if you gave me a negative number of seconds, that don't do that anymore, right? It's a negative number of hours, negative number of minutes, negative number of seconds, right? But I could do that easily enough. Okay, so maybe we need to make a firm thing about, the numbers must be positive, that sort of thing. Okay, that's going to give us what we need for minutes and seconds and hours. So why don't I'm going to make functions because that's what the topic of this week is. So I'm going to have get num hours and unsigned int. Let's do an unsigned int. All right. I'm going to put my little blueprint down. I'm not going to return it. Or I can just do this. Let me do it this way. It's easier to do it this way. We'll use a prototype way. All right. So I'm just going to keep on, I'm lazy. I'm cutting and pasting. Okay, get number of minutes, seconds. All right, I have three functions, haven't defined them yet. Okay, I'll define them in a second. These are my what are called prototypes. These is I owe you one function called get num hours. I owe you one function called get num minutes. I owe you one function called get num seconds. If you don't implement them, bad things can happen. Normally you go and fill them in. But this way, if you put them at the top, other functions know it's all being run line by line. So if some function needs that up here, it goes up there, goes, oh, you do have a function called this. Where's that defined? Oh, it's down here. Boom. And you can that way you don't have to worry about the order in which you've defined your functions. It is purely for you to, and it's a bad habit of mine. I keep on defining these, at the top and having to worry about the order. But a prototype, so these are our prototypes. I owe you a functions, right? This is what you owe this, your code. I have to go and fill these in. So I'm going to go and fill these in. Here's me filling them in the worst possible, not worst possible way, but me filling them in a crappy way. And I probably should have comments in here, but return 0, return 0. And why the heck am I doing this, by the way? You probably are wondering, what is wrong with this guy? He's crazy. And the actual answer is, I want to have a high level view. I want to figure out what my plan of action is, and then I'll implement those things later. I have it in my head right now. I should have written it on paper, but I'm doing it in front of you guys live. Every single time I'm coding anything, it's just you plan, then you execute, and then you test, and then you write a bit more, and then you test. Okay, so here's what I'm going to do. I'm going to have some starting number of seconds. Um, 02030. Right? That's what we used as a number. So why don't we use that again? Okay. Um, I'm going to, so I made a variable, which is seconds. I'm going to, maybe I should say raw seconds. It's the total number of seconds that have passed. I'm going to make some new variables. So, and I'm going to call my function get num seconds, and I'm going to say raw seconds. This is the thing going in is this number. I want to test my code out. I'm just testing. I'm going to make another variable here in a second. Just pure laziness here. Minutes, hours. And we'll play around with this. Okay. I'm getting three different numbers, the number of hours, the number of minutes, the number of seconds that have passed since that beginning time. Okay, then I'm going to put a printf statement here just because I can. I think it's for unsigned would be U. I got to double check that. Maybe it's Unicode. So let's put a U in there and let's find out. I don't know. Um, one of those things you look up. Hours, minutes, seconds, new line. Why? Because I want something that I can check what this data looks like, what these data look like. Raw, and notice I have four variables in that order. It's raw seconds, hours, minutes, seconds. All right, fine. I don't know how this is going to work out for me, so let's just compile it and see what happens. And I'm also going to let's comment out the other. Oh, must return a value. Hey, didn't return a value. I'm doing a little bit at a time, then testing. A little bit at a time, then testing. Because if I wrote all my code all at once and did everything and then tested it, I wouldn't have one simple little error here. I'd have like 20, and I wouldn't know which one was first. I wouldn't know if there's some kind of weird interaction effect. So return 0, fine. Pilot. Let's see if it works. All right, it worked. That's good. Every once in a while, it doesn't work, and it's a pain trying to figure it out. But I'm sure all of you can figure it out. It's just it's a pain. Oh, I need to also return a value. Google's messing up my code here. All right, return one. My main method, if it's a void, I don't have to return anything. But if something error, I think it's Google. Yeah, Google. I should, if for my main, it says it's returning an integer, I should return an integer of some sort. Okay. This is going to give me the wrong answer if you hadn't been able to tell. That's okay. I want it to compile. I want to be able to test out what happens. I want to see what's going on. So let me move this over and let me show you what happens. The raw, its number of seconds is 0 hours, 0 minutes, 0 seconds. Okay, clearly wrong, but it's a start. Now my question is, how do I go about doing those other parts? And maybe what I need to do, maybe what I want to do, make one more function with this whole thing and have, let's do a void function and say print time from seconds. And I'm going to take some raw number of seconds. function. So I can put it here. I can put it up there as a prototype. It doesn't really matter. Okay. And instead of all of this, I'm just going to take this, rip it out. We'll have to change raw seconds to seconds past everywhere, but that's fine. All right. Here's a void function. It takes some input, the number of seconds the total number of seconds, raw number of seconds that have passed, figures out the hours, figures out the minutes, figures out the seconds. Doesn't do it correctly, but it's me organizing my code. And now what I could do is I can say print time from seconds and raw seconds. And then I could do the same thing for, let's try 0. I want some test cases. 60. What is 3,600, I guess, right? What other things might I want to try? Ooh, that's a nasty one. What if I try -1? What does this thing take in? It takes in an unsigned integer. -1 is a signed integer, as in I can't have negative values with unsigned integers. They're only positive. They go from 0 to the largest possible number we can represent with 32-bit. Signed integer, half of the numbers are for negatives, half the numbers for positives. That's why we looked at numeric conversions. I will say that -1 in binary is a huge number. It's the largest number we can actually store in 32 bits in this case. So I'm expecting a very large number, and I'm going to, just because I can, I'm going to go to the side here. See if you can see my mouse. And I'm going to just click here, and that puts a breakpoint. So all I do is click, or I can F9, 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 F9. Right. It's meant to be fairly easy to drop one of these things in there. It's just a stop sign in your code. It stops it there. You can look around at things. Okay, let's run this thing. It's going to be wrong still. That's fine. So because I put it in a function, it means I can do the same actions with one call. I call print time from seconds, and let's put a breakpoint up here. I'll print time from seconds. I will jump to some other piece of code, do that code, go back, jump to some other piece of code, do that code, come back, jump up, come back. I'm still doing one instruction at a time, but a function allows me to take some chunk of code that I'm going to do all the time and sort of deal with it in a sort of, sorry about that. Trying to let me see my screen at the same time because my breakpoint's there. Okay, so I'm going to step into the function. There's a whole bunch of things up at the top here. You should see stop debugging, reload. I think this is show next statement. Step into the function. So it will go into whatever this thing is pointing at. In this case, I will go into the function print time from seconds. The next step will be to jump up here, do these steps, jump back, jump up, do these steps, jump back. Okay, so I'm going to step into the function. I've jumped from here. I'm now calling this function, and the number of seconds passed. Oh, wait, this variable is called raw seconds, but the variable right now gets set based off of what calls it. So right now, seconds passed is 102030. I will then calculate the number. I'm going to go to the next step, step over F10. I'm going to step over again. So number of seconds passed, 0. I can just hover over this thing. 0. Minutes, 0. Hours, 0. Great. And then I'm going to print off this whole thing. Raw. Okay, let me move this over here. So printf statement gives me. Great. I finish off the next step. And now I'm on to the next line. I'm looking at this thing here. So we can jump into that function. and I can go step by step. Number of seconds passed is now equal to 0. I make this variable number of seconds pass is set, is created each time I call the function, and it's set by the value that's calling it. So the 0 seconds pass is equal to 0. Next time I call it, seconds pass will be equal to 60. Next time I call it, seconds pass will be equal to 3,600. I just jump up, set the value, and do a bunch of stuff. So seconds pass is still 0, still going to give me 0 for all these. I have to fix these in a second. I have a printf statement. Okay, I go to the next step. Then I'll be testing for 60, then 3,600. So if I do F10, I just go to the next step. And let's do one more next step, and we'll try -1. Oh, sorry. And we want the point back. All right, I'm going to walk down this thing. So what is seconds passed? Oh, that's a big number. Why? Because it's -1, but as an unsigned integer. It's the largest number I can store as a 32-bit number, as a 32-bit integer. It is a very, very large number. Look at this thing. It's, let me see here. 4,294,294 million, right? It's a big number. And number of seconds passed is 0, 0, 0, and a print out some number. Okay. I also want to check something out here. What does this thing state? Oh, so U is actually working correctly. Look at the size of this number. Because I had a percentage U, it didn't do an integer, it did an unsigned integer. It's this colossally large number again, because it's an unsigned integer. That's what the percentage U is. Percentage I is, or percentage D is for a digit or an integer. Percentage F is for a floating point number. Percentage C is for a character. There's a whole bunch of these things. And I don't memorize them. I just figure out when I need them. I don't know what a hex is. Let's look up what the printf statement does for that. Okay, let's also close off some of these things. All right, let's fix up some of these. So we've hit breakpoints, we've hit functions, we've hit the clock example. We actually have to do the clock part now, but let's do that in a second. And then we can do the random. The random stuff is kind of weird. So number of hours, how would I do this? Well, let's do one thing at a time here. So what do I know? How I could keep it as a constant somewhere, or I can just use the number 60. And let's use a constant. So the one time I'm allowed to have global variables is their global constants. So constant. Uh, this is never going to change. I'm not allowed to change it because I have this thing here. It's not a variable. It's a constant. I'm out of luck if I want to change it. Or I could have just typed in the number 60 because that's not ever going to change. Other times you might want things to change though. I want to completely change this one. Minutes per hour. All right, 60. So what do I need here? I want seconds passed, and I want to do the remainder. That's ultimately what I want, is I want how many seconds have passed. But if it turns into a minute, like 61 seconds should be 1 minute, 1 second. In this case, I want 1 second. I need a remainder. So the remainder, if I take this number and I remainder with seconds per minute, what will this give me? Even with a ridiculously large number, if it's a multiple of 60, it gets removed. Everything but multiples of 60 get removed. Okay, that should give us the exact like raw number of seconds. 61 raw seconds would be 1 minute and 1 second. I want it to return 1 second. All right, how about this one? So I could say seconds passed divided by seconds per minute And I'm hoping that's going to do it for me. Or is it going to do that for me? Is it going to do the right thing? Let's find out. All right, let's go on it line by line here. That's a lot of minutes. In fact, we said it wasn't the right number of minutes because there's a couple hours in there. There's 28 hours in there. Okay. Oh, we also need the number of hours per day. I'll have to put that in there. Okay, so for 0 seconds, I get 0 hours, 0 minutes, 0 seconds. For 60 seconds, I get 0 hours, 1 minute, 0 seconds. Okay, that works. 0 hours, 60 minutes, 0 seconds for 3,600 seconds. Great, that works as well. But that's wrong as well. That should be 1 hour. Okay. And what about this crazy number? It's a crazy big number and 15 seconds. Okay. I'm just going to continue and just finish up. So if I press continue up here, this just starts it up again. Like it doesn't start from the beginning, it starts from wherever you are and continues on. I need to do this. This is what I had here. This, in case you're wondering what I was reading out. Here it is. This number is way too big. This number is right. This number is right. This number actually, this should be 1 hour, 0 minutes, 0 seconds. Right? My test cases are based off of things that I think are going to be problematic for my system. What's going to be problematic when it goes from like 59 seconds to a minute. As soon as it gets to a minute, it's supposed to flop over to the next one. That's what we're aiming for. Okay, so, and this is huge. So we need to go back to the drawing board a little bit. It's not wrong. It's part of the way. So constant int uh, hours per day equal to, um, we want to say hours per cycle, hours, let's say cycle is equal to 12. If I did hours per day, 24, but I might want to have different versions. I might want to have get number of hours, get number of hours 24 for a 24-hour clock, where it does it the math a different way. Okay. So what do I need here? So I have, if I divide it by the number of hours, let's see, the number of minutes per hour, what do I get? That's still not going to be right. What I want is 3,600. I really want like 60 times 60. So one thing I could do is say, like, figure out the number of minutes and then divide that. But then the number of minutes, I want that to be fixed up and the whole thing. So I'm trying to plan out my attack. The way I'm looking at this is I want to figure out the number of hours, and then, or what's the best way to do this? I want to figure out the number of hours. I want to figure out the number of minutes. Well, let's do subtract the number of minutes and then divide by that. There's a bunch of different ways I could do this. So let me think about this. I have the number of, if I figure out the number of minutes that have passed, can I use that to my advantage? Maybe. If I have the number of hours that have passed, can I use that? Yeah, I could use that thing as well. Or I could just redo the calculation each time. So what I want is I have the raw number of seconds. I could figure out how many minutes in total there are and then divide that by 60. But then I need another function for calculating the correct number of minutes. Okay. But really what I want is once I have the number of minutes, and I know how to calculate the number of minutes is right, it's approximately right here, then I'm going to divide that by the number of minutes per hour. So essentially, it's the same as saying, just based on math. And you would play around with this a little bit. Number of minutes per hour and the number of seconds per minute tells me how many seconds there are in an hour. Okay, and so I take the number of seconds that pass, divide by the number of seconds per hour, and we'll see if that works. I also want to put some parentheses around this thing because I want to make sure that my order of operations are right. I don't know if it's going to do this division first and then the multiplication or what it's going to do. I actually do know it's going to do the division first, but that's what we're looking at. Okay. the minute's still going to be wrong. But let's have a look at this thing. Let's do a little bit. Compile it. Does it compile? All right, it compiles. Okay, and we're going to look at this. And I'm going to take off my breakpoints now and just press continue. Just go. I want to see this fast. There's a problem with Visual Studio with that sort of thing. Okay, so 28 hours. Oh, that's not right. That's not right because I should have removed those hours. So we've got to fix that. Number of seconds is right. Okay. But 28 hours is not right. That's right. That's right. That one's right. This 60 minutes is wrong because it should be removed. And okay. And then this one is correct. That's really over the top as well. Okay. Oh, that's the number of minutes. That's way over the top, and that's way over the top. Okay. So what I need here is I need to figure out how many minutes, how many hours have passed, and then do a division. So I can do it all in one go, or I can try and do something fancy stuff. Let's do something fancy, just all in one go. I normally don't do this. I would normally make another variable and then do the calculation so I can actually see what happens. So, well, actually, let's do the slow way. Let's quote unquote slow way. Unsigned int raw hours. Return, and then I need to have the raw number of hours. Right? That's how many hours. If I have 28 hours, I actually want the remainder. If I divide it by 12 a bunch of times, I want 4. That's what I actually ideally want. And so that would work just fine. Let's put that. I overused parentheses. I didn't need the parentheses here, but I put them in anyways because I like being paranoid. Okay, that's the number of hours that have gone by. Let's check our code one piece at a time. What do we got? 4 hours. Okay, that's looking better. That one's right. 0 minutes, 0 seconds. Fine. That's fine. That's fine. And 6 hours. I have no idea what the number should be, but I know it's not this for minutes. Good. So for the hour seems to be right. Maybe I want to do a couple other tests. Maybe I want to test for particular amounts of time. Okay. Then what's next? So that's going to be correct. What I want is, let's see, what could I do here? I could figure out the number of hours that have passed, subtract that multiplied by, let me see here. What's the best way of doing things? Because I'm not going to have I don't want the raw number of hours. Oh, let's do the same trick as I did last time. Okay. I'm just gonna, okay. And then I want raw minutes remainder, and then I can put this number of minutes per hour in there. If I do that, it'll get rid of all of those other numbers, right? It's just the remainder. It's going to be some number between 0 and 59. If it gets to 60, it's on another hour and it goes away. That's actually what the beautiful thing about a clock. It cycles around. That's why it's a circle, right? So as soon as you get to the 1 hour point, I start off at 0 again. That's what the remainder gives me. The remainder looks exactly like a clock. It goes around, and then as soon as it gets to that point where it flips over, it starts again at 0. So think of it like that's why we use clocks as the metaphor here. All right, let's see this thing in action. Let's see if it actually is working correctly. Okay. What do I have here? 6 hours, 28 minutes, 15 seconds, 100. Okay, that's actually looking correct. Great. And if I want to test something else, what could I do? Let's plop it. If I wanted to, I could also, this is the reason I do it this way. Run it. I get my breakpoint. I'm landing on my breakpoint. You can see the raw number of minutes. Notice it's a really big number. It's at the start. It looks weird because I haven't done the calculation yet. One step down. Now I have a calculation. It's 1700. And then I can do the calculation. 1700 divided by remainder 60. How much is left from that? It's not. It's going to. This is minutes. 20. Do another breakpoint, and I'm just going to turn that off. Clicking F9 and clicking the button and press and play. Now, my question is, what other ways could we test this thing? Well, what if there's a whole bunch of ways I could test it. So let's do another way if I could test it. Get raw seconds. And then I could have unsigned in hours, unsigned in minutes, unsigned in seconds. If I wanted to do this, right, I could have a function that takes in 3 different numbers, generates how many raw seconds there are, and what I would expect is if I then reverse engineer it again, I get the exact same numbers. That's what I would hope. So that would be something I could play with. So sign int raw seconds. Oh, I need to move these numbers, these raw numbers here down to the top. I need to find those at the very top because it won't know about those variables until I use them. Oh, I want to do randoms. So this is going to be hour, type hours multiplied by minutes per hour multiplied by seconds per minute. I'm going to modify raw seconds again. Use this particular operation means plus this number and save it back in, or I could say raw seconds is equal to raw seconds plus some other number. So I'm just adding to the original number. Plus equals is the same as equals raw seconds. Well, let's keep it the simple way. Raw seconds plus, and now I need how many minutes multiplied by second hour per second per minute. Let's do it the fancy way now. Plus equals. That's the same as the line above, and that's going to be sec. And I could use this somehow. Or how do I want to say this? Could be useful for testing my code. Like that. The point of the assignment was one other thing, and I need to figure out what this thing is going to do. So let's try it out. I needed to get some raw value. I need to get some just random, not raw, random value. So maybe I want rand dot, is it rand dot? It's one of the functions I was told to use. And I don't know what this, it's unidentified. Okay. I also have rand. Let's see if that is do something here. Huh. I think we have there's something in the header file that we needed. So I'm pretty sure I gave you this, but I'm hoping, and if I didn't, I need to give you this. I think it's the random library. That's where I always get screwed up, right? How do you need to know this? I don't. I look it up. I go into Stack Overflow or something like that and say, like, where's the rand function defined? It says, oh, it's defined in the random library. You just plug in the word random up here, right? It's finding it on my system. By the way, there is a difference between this and when you have quotes. When you have quotes, it says, look locally. The files that are in your folder right now, look there. I have this, it says, look on the systems libraries for that particular library, those particular files. Okay, does that actually work? Rand is working. It's returning an integer. It's a random integer. Okay, it's rand. Okay, I need a semicolon out here. All right, I'm going to change this around. So I had a question about this earlier. What the heck is rand and srand doing? What's the S stand for? Super? No. srand is for seeding the random number generator. What is the hell does that mean? The random number generator is not a random number generator at all. It's a pre-made random number generator. You have the C does not actually make true random numbers, or at least not using this. It already made this gigantic lookup table of random numbers, like enormous lookup table of random numbers. Let's, hundreds of thousands, presumably, of values. And then the question is, if I start at a random position in that table, let's say position 497, and start there, and then get the next number, next number, next number, next number. If the original table was purely random, and I choose a random position within that table and start reading off one after the other, it effectively looks random. It's not really random, but it looks random. You don't know where you're going to start, and then the next numbers are going to look effectively random. You can't, people can reverse engineer it and try and figure out what it is. You do enough get enough random numbers, you can figure out exactly where you are in this gigantic table. But for our purposes, good enough. So seeding a random number generator, I can put like the number 0 in here, and that would say, go to position 0 in this random number table. That's where we're going to start. The very start of my random number table. If I put 100, I always start at position 100 and get the next numbers. So it's not random at all in that case. I'm just pulling up the same numbers in a row each time. If I put a semi-random number in there, like something that I can't really predict, then I get random numbers. So if I put a 0 or something like that, I will get the same behavior every single time I call my functions. But if I do something like time, I put it in the lab itself, so I'm going off of memory here. Anyone know what I wrote for the lab? It's like system time or current time. I always mix up all my various things. Oh, thank you. Time null. What the hell is that? That is whatever the heck the computer uses for I think it's millisecond time on the computer. It's effectively a random number when you call this thing. So I'll need time as well. Oh, here's why you can probably do this. Add time.h. There you go. Hey, they put time.h in for me. That's great. Right? Sometimes they give you the ability to complete it for you. Okay, that'll give me a random number. Now, if I get a random number, say int, this lost seconds 2 or something like that. What's this going to do for me? It's a random number, right? But is it in a particular range that I want it to be? Not necessarily. How do I make sure that it's in a safe value? Let's say between 0 and 100. How do I prove that? Okay, so let's do this. It's going to be an integer of some sort format. And let's put a new line in here. Let's put some dashes just to make it look pretty. Sort of pretty. All right. Let's see what this thing gives us. Compiled, good. Here's my random number. If I call this function again, it'll be a different number. It's also a really big number. Okay, 13,176,867. But if I want that number between, let's say, 1 and 1,000, 1 and 10,000, 1 and 100,000, what could I do? So, do we have any tools available to us to help us with that? Oh, thank you. Oh, that's actually wrong. Thank you. Aha. See, it told me what the error was going to be. Look at this thing. It's looking for a number. I didn't give it a number. So I have to look at this again. Let's see if that works. There we go. You can have bugs in your code while it compiles. Compiling is not the same as working. So I just found one of those examples, right? I didn't put a number in here. It gave me a warning because it gave me a green underline. Still going to be some crazy number. Okay, here's a crazy number. 10,076. Okay. Now, if that's the number range you want, that's fine. We can deal with that. We can do, we can go with a number like that. Maybe I don't want that number. And or if I run it again, see what I get. Okay. That's surprisingly similar. So this ran is fine. Huh, okay. But it's not the same number. Let's try it again. Oh, these are really consistently landing in the same area. That's really annoying, actually. Fine, because that's freaking me out a little bit. They're way too close together. Okay, but still, it's a random number, fairly random number. So what should happen is I start some random position in this time, a random position in the table. And after that point in time, I just call rand every time I need a new random number. And let's get another number and let's put a breakpoint just because that's freaking me out a bit. Okay, and we're at our breakpoint. Raw seconds is equal to 10,386. And then the next step is 33,411. There's something weird going on with this random number generator. Anyways, good enough for us for right now. And so if I continue, what should happen is I have 23411. Let's say. Okay. What I want is this is giving me some bunch of random numbers. What I really want is to maybe I want it in a particular range. Well, if I want to make sure it's between like 0 and 100, what could I do? Well, if I have a random number and I do the remainder by 100, let's say, what do I get? Let's try it. Let's do. What will that be? Let's think about it for a second. No matter what the number is, if I do remainder 100, it's effectively going to be a random number between 0 and 99, not including 100, and be consistently that number, 0 to 99. And if I wanted the numbers between 100 and 200, not including 200, I just add 100 to that. I start at 0, push it up or push it down. I have this window of 100 numbers using remainder. No for loops, no looping of any kind, nothing crazy, just remainder. It does so much stuff for you. It's really quite an incredible thing. To the fact that I didn't learn it until I was in industry and went, oh, that's a really useful operation. That's really nice. Right? Remainder allows me to do all sorts of things, including this is some number between It's a range of 100 elements from 0 to 99, guaranteed. Okay, so that's my random number here, and let's do, and then I'm going to print time seconds over here, put it at the very bottom. Why not? 2, and I'm going to remove my breakpoint because I don't need it anymore. I'm going to run this thing and see what happens. Okay, here's my random number, 5,109. I have a bunch of numbers. This breaks down into 1 hour, 25 minutes, and 9 seconds. Works for me. And that's effectively flat. So we've covered, what have we covered? We covered remainder. We did a bunch of printf statements using unsigned integers in some places. Right here, using unsigned integers. If you want, let's put an I in here and see what happens. We also looked at functions, which is this week's topic. We looked at remainder in a whole bunch of different ways. We looked at how we can methodically break down our code. I played with an idea and then methodically worked on it. I did a little minimum amount of code at a time, compiled, minimum amount of code, compiled, check. And I checked each and every time I did one little new part, check to see if the next part I worked on worked as expected, and moved on from there. I didn't write all my code and then test. I did a little bit at a time. It seems like that would be slower. You would think it would be slower. It is radically faster than trying to write all your code at once, because no matter who you are, no matter how long you've been programming for, honest to God, no matter how long you've been doing this, you will still make stupid little mistakes along the way. And if you rely on all this, like this, write all your code and then test it, those stupid little mistakes all add up because you won't be able to find them anymore. It's trying to find a needle in a haystack and you've added extra hay for no reason, right? You want a little bit, needle in a haystack's easy if you only have a little bit of hay, right? If it's a little pile of hay and a needle, it's easy. If it's an entire barn, it's hard. That's why we do it a little bit, because everyone has a needle in a haystack problem regularly. You're getting in your own way if you try and do everything all at once. Okay, so here's what we have. And it shows the -1 now. Notice it doesn't show this gigantic integer anymore, a gigantic positive number anymore, because I said I instead of you for that percentage thing right here. So we looked at printf statements. We looked at breakpoints, how to use them, how we can hover over things, and we looked at, what other things do we look at? And the lab itself, and how we can break down our big problem. Other issues, concerns, queries. I mean, I talk a lot, so I'm more than happy to stop here if you want to just take off, or I can answer more questions. Is that everything, guys? If you have no more questions, I'm more than happy to let you go, but I didn't know if other people are concerned or have other clarification questions. Well, you're welcome, Terry. Okay. Silence is golden. Maybe not. Silence is terrifying a little bit. I want to make sure everything's feeling good. Everyone's feeling good about this. It's if you're new to programming, the key is just practicing. Honest to God, it's not magic. People, when they see people play piano really well, they go, "Oh, you must have a gift." You're like, no, it's practice. Just practice. There's some people that have maybe a bit more of a natural gift than others. I'm always going to be a clunker when it comes to pianos, especially with these fingers, but it requires practice. About the breakpoints, I understand it's optional, anything, but I'm wondering what's confusing about it. So I go to the side where the gray boxes here. You can see my mouse, and I click. And I want to take it away. I click it again. That's the entirety of what a breakpoint is for. It's a stop sign in your program so you can look at what the data looks like. That's it. And you can walk line by line. like a slow-mo replay, because I just watched Super Bowl last night, right? Slow-mo replay of all these things, or frame by frame look at all these things. So I'm trying to figure out what the confusion is. It's not that it's not meaning, it's not necessarily confusing or anything. No, absolutely could be. It's just I'm trying to figure out how to address your question. Part of it is just run your code now, drop a couple of breakpoints, see what happens to a certain extent. And again, the big thing is once you have it down, you click it again to get rid of it because it'll drive you nuts if you don't know how to remove it. Brag is a jerk. Broke my code. Nope, just click on the side. And we're not talking like breakpoints based on variable changes and stuff like fancy breakpoint stuff, which I have to look up each time when I need to use them. We're talking that line. I stop when I get to that line. That's it. That's all a breakpoint. That's all we're doing with breakpoints. That one little thing will make this course tolerable, hopefully. Right? Because everyone goes, I don't know what the problem is. I go, did you put a breakpoint? No. And you can actually figure out exactly what your code is doing. A breakpoint and a little bit of deductive reasoning. Why is it that number now? Oh, weird. Right? If I have something weird on this line here, let's say on line 52, okay, maybe I need to put a breakpoint on line 49. Maybe I need to figure out maybe this variable being passed in here is a weird variable like -1, and I expect it to be -1, and I get this huge number, and that's what's causing the problem. So I have to go and I can check out what things do. I will show one more thing about breakpoints. Let me run it and show you something. Okay, I'm at a breakpoint. I just clicked here, put a breakpoint down. But you'll notice on the side here, I have something called the call stack. I don't know if you've seen this. Hopefully so you can even look at your breakpoints, here are your breakpoints, here are your exception settings, a bunch of other stuff. But the call stack is the one that you need or might want. The call stack, notice if I go click the next line, where am I? Right here. It is where I am, where I go into, where I go into. I have the path like an Amazon account, right? When you start on when you're doing an Amazon order, you'll see like electronics, solid state drives, like a bunch. It's a hierarchy. Like this goes to this, that goes to this, goes to this. So when I break here, I can actually see what the variables look like out here in the previous function that I was in. If that function's in a function within a function within a function within a function, I can see all of that, the entire trace back all the way. So if I have a breakpoint, I can see what called it, what called it, what called it, called it, all the way back, which is really useful sometimes. You're probably not useful for this assignment or the next 10 assignments. 2400 probably very useful. All right. Everything okay, guys? Then I'm going to take my leave of you guys. Then thank you very much for listening in on this, and we'll stop sharing here. I can make sure this code is available for you guys. It should be. This is the code I was playing with for the programming guide. That's also shared with you already, but I can make sure it's available in the sync lecture. All right. Well, thank you very much, everyone. Thanks for your attention, and I will hope you have an easy time. Just let me know if there's other questions that pop up for the assignment. All right.